Hello everyone. Good afternoon to all. How are you all? Hello Zenbi Visakhapatnam. Hi all. Okay. Yeah. Hello everyone. Good afternoon to all. I'm launching the technical polls. Sorry. So let me know in the chat box whether my voice is clearly audible to you or not, and also about my screen, it is visible clearly or not. Let's respond in the chat box whether my voice is clear or not and my screen is visible clearly or not. Yeah, Jane B. Maya and Jane B. Visakhapatnam. Can you respond in the chat box, please? Shall we move? Everything is good? So we will move, huh? So, okay. Oh. So guys, today what we are going to do actually, we'll discuss the last paper exam, test paper. Okay, AIET test paper discussions will be happening today. Okay, so let's start from the first question. Here you in your screen you can see this is the first question, number 51 question, where you are asking to find f of x is equal to find the range of the function f of x is equal to greatest integer function of x upon 1 plus greatest integer of x. That means there are some options given, 4 options given, which is not correct. You have to choose which is not correct. Okay, so let's start. So the function is given as f of x is equal to greatest integer function of upon 1 plus greatest integer of x. That means if I'll ask you to find the domain of this function, so what should you do? Because in the option A we have the domain of f of x is r minus semi interval of minus 1 to 0, right? Clear? So first we need to find the domain. Then in the second option is mentioned that 1 does not belongs to the range of the function f of x. That means you need to find the range also. Okay, and the range of f of x will be set of integers. That means it belongs to the range. Option D is none of the options are incorrect, right? So first what we'll do, try to find the domain. What is the domain of this function? To find the domain of this function, what should you do? This function to be defined, my denominator must not be equal to 0. If denominator becomes 0, then this function will not be defined. That means in the denominator we have 1 plus greatest integer of x, which is not equal to 0. So that means greatest integer of x must not be equal to minus 1. Yes or no? So when greatest integer of x becomes minus 1, now when x belongs to minus 1 to 0. Is that clear or not? Yes, that means domain of this function will be r minus domain. What is domain? Domain becomes r minus minus 1 to 0 when minus 1 is included and 0 is excluded, right? So domain becomes this. So in the first option it is mentioned that domain is r minus minus 1 to 0. That means it is correct. It is correct. Next we need to check whether what is the range of this function. What is the range of this function? The range will be, how we can find range? The range, first the method is we need to write the function as y is equal to greatest integer of x upon 1 plus greatest integer of x. Okay, then cross multiply. After cross multiplying, what you are getting? Y into y plus greatest integer of x into y is equal to greatest integer of x, right? If I take the y as common, sorry. If I take this to this side. So what will happen? It will be y is equal to greatest. If I'll take the greatest integer of x as common, then I will be having 1 minus y. That means here I am getting greatest integer of x becomes y upon 1 minus y. So to find the range, that means that is equal to find the values of y, because y is the set of all y values are set of all outputs. So we need to find the range. That means we need to find the all values of y. So when y is equal to 1, so this greatest integer function of x is equal to y upon 1 minus y. That means this will not be defined. This box of x is not defined when y is equal to 1. Is that clear? When y is equal to 1. That means y can't we take the value 1. Is that clear to everyone? Y can't be 1. That means my range becomes, range क्या हो जाएगा मेरा ना, range becomes, sorry, range will be, what is the range? Now y does not belongs to the range set. Range, sorry, 1 I'm sorry, yes, it is not y, 1, and y1 does not belongs to range, because at y is equal to 1, this greatest integer of x does not define. Is that clear to everyone? So option B is also correct. Okay, if option A is correct, option B is correct, then check whether option C is correct or not. The range of f of x will be the set of all integers. No, never. Why? Because y in the range set 1 is not belongs to. That means 1 is an integer. If 1 is an integer, how can you say the range of f of x will be set of all integers? It is incorrect. Simple, it is incorrect. And the correct option, the answer is option C, which is not correct, because it is mentioned that f of x will be the set of all integers. The range of f of x will be the set of all integers. But here we are finding at y is equal to 1, greatest integer function of x is not defined. That means y cannot be 1 for greatest integer of x to be defined. That means y cannot be 1. So that means in the range set, while not 1 is not present. That means it can't be the set of all integers. It can't be set of all integers. The correct option is C, and which is not correct. Option A is correct, option B is correct. Is that clear to everyone? Please respond in the chat box if it is clear to all. Guys, clear? Shall I move? Okay. This is the solution. What we have explained, this is the solution in your screen. Clear? Okay. So let's move to the next question. Here, you have to find the domain of this function. And okay, so how we can find the domain of this function? So if you remember, when we have something in under root, this function to be defined, this something must be greater than equal to 0. Is that clear? This something must be greater than equal to 0, because we know always under root of something will give us a positive value. And we know how to find the square root of a positive number. Okay, also 0, we can include 0 also. Okay, so this function to be defined, something must be greater than equal to 0. What is domain? Set of all outputs. That means, sorry, set of all inputs. That means the set of all values of x for which function is defined. So if we use this rule, then we can find the domain of this given function. That means here what we have in the under root, that is log of greatest integer of x square minus 5 to the base 4 to the base 1 by 3 must be greater than equal to 0. Clear? Clear or not? Yes? Okay. You know, when from the logarithmic inequality we know what is that log of x to the base a to be defined, this to be defined, x must be greater than 0. Argument must be greater than 0 always. That means here we can say log of, in the log first argument, in the first log argument is log of box x square minus 5 to the base 4 is greater than 0. This to be defined, total, this to be defined, it must be greater than 0. Yes, yes. And also from the logarithmic inequality we know when suppose you have x1 is greater than x1 is less than x2, we'll take log of x1 to the base a and log of x2 to the base a. If a is greater than 1, if a is greater than 1, then the sign of the inequality will not be changed. If a is lying between 0 to 1, the sign of the inequality will be changed. In this case, after taking the logarithm in the both sides of this inequality, x1 is less than x2, what will happen? Log of x1 to the base a will be greater than log of x2 to the base a. So these are the concepts we will use in this course. This is all about your logarithmic inequality. Clear? Okay. And also to find the domain of this type of function, what you have in the under root, that must be greater than equal to 0. So let's see what is the solution of this question. Okay. See, already I told you what you have in the under root of the what you have in the under root, that must be greater than equal to 0. Then the argument of this log, argument must be greater than 0. That is, here we have mentioned this is greater than 0, right? And if we'll take the logarithmic inequality also, if you have log of 1 by log of x box x square minus 5 to the base 4 is greater than equal to 0. Okay, if we'll take antilog on both sides, or you can say if we'll use the standard, antilog to nahi ho sakta hai, standard property, standard law of logarithm. If a to the power b is equal to c, then we can say log of c to the base a is equal to p. If we use this rule here, so what will happen? Here you have log of, reverse wise it is there, log of c to the base a is greater than equal to b. Then what will happen? It will be a raised to b greater than equal to c. Clear? If a is greater than 1, if a is lies between 0 1, then the sign of the inequality will be changed. So here the base is 1 by 3. So 1 by 3 is lying between 0 to 1. That means here we can write log of box x square minus 5 to the base 4 is less than equal to 1 by 3 to the power 0 by using this law. Okay, that means here 1 by 3 to the power 0 is 1. So here we are getting this log of box x square minus 5 to the base 4 is greater than 0 and less than equal to 1. This step is understood. Clear? Okay. Then if we'll also ये जो log of log है ना अभी, ठीक है, till now we have another log, ठीक है. If we'll use the rules of logarithmic inequality and again we'll simplify this inequality, what will happen? See here, the base is 4. The base is 4. That means if we'll delete this log, so what will happen? This 4 goes to left side of the inequality also and right side of the inequality also. Okay, left side becomes 4 raised to 0, right side becomes 4 raised to 1. And because 4 is greater than 1, that's why the sign of the inequality will not be changed. That means, okay, so box x square minus 5 is 4 to greater than 4 to 4 raised to 0, that is 1, and less than equal to 4 raised to 1, that is 4. It is clear now. See, if we'll add positive 5 with all of the terms of this inequality, then what will happen? 5 plus 1 is 6, and minus 5 plus 5 will be 0. That means what we will have? We'll have box x square is less than or equal to 4 plus 5, that is 9. Okay. So now you can understand we know always box of x is an integral value. It is an always integer. If it is an integer, then it is also an integer. Integer square is also an integer. So in between 6 to 9, in between 6 to 9, there is only one perfect square integer value possible. So what is that? That is 3. Mod x is equal to, sorry, box x is equal to 3. So 3 square is also 9 and minus 3 square is also 9, right? So box x can be 3 or minus 3 and minus 3. Then by solving this inequality, greatest integer of x is greater than greater than 3. Okay, so it will be box of x, greatest integer of x, we are getting here 3. Okay, so that means for which values of x greatest integer function of x will be 3, that means 3 to 4, when x belongs to 3 to 4. And when we'll solve greatest integer function of x is equal to minus 3, so for which values of x greatest integer of x will be minus 3, that is when x belongs to minus 3 to minus 2. So by taking the union of these two intervals, we will get the domain, that is minus 3 to minus 2 union 3 to 4. Clear, everyone? This is your answer. Is that clear to everyone, guys? Clear? Okay, how many of you attend these questions in the examination? How many of you? And got the correct answer also? Yes? Anyone? So let's move to the next question. That is here. Okay, it's an easy question, so you can solve it easily. Here also, if x belongs to R, then solve the given inequality, that is mod of x minus 1 plus mod of x minus 2 is greater than or equal to 4, right? So it's a absolute value inequality or modulus inequality. You have to just solve this inequality. So how you can solve this? How you can solve this? First I will suggest you to find where the left hand side becomes 0. Where the left hand side becomes 0. That means at x is equal to 1 and x is equal to 2, the left hand side becomes 0. Simple. That means the critical points are 1 and 2. So this left hand side will change the nature by at this point only, at these 2 points only. So what will happen? There are 3 cases arising. So what are those cases? First case is when x is less than 1. Case 2 is x is lying between 1 and 2. And case 3 is x is greater than 2. So what will happen when x is less than 1? See here, when x is less than 1, so this becomes, that means x minus 1 will be negative. So we know mod x is equal to, how we can find? How we are defining modulus function? That is, when x is greater than or equal to 0, this gives you positive x, and when x is less than 0, this gives you negative x. So in place of x here we have x minus 1. So when x minus 1, when x is less than 1, then that means the input, x minus 1 will be is actually negative. So if it is negative, then the modulus will open with negative sign. Is that clear? Negative sign. Okay. Similarly, here also x minus 2, if x is less than 1, it is also open with negative. Then at when x is less than 1, this will opens with negative sign. Modulus will open with negative sign. So negative of x minus 1 minus x minus 2 is greater than or equal to 4. By solving or by simplifying, we are getting It's very simple inequality. Na? We are getting x is less than equal to 1 minus 1 by 2. Similarly, the second case, in the second case, when x is greater than 1 and less than 2, greater than equal to 1 and less than equal to 2. So the modulus is opening with positive sign. That means जो भी है वही रहेगा, x minus 1 minus x minus 2. ठीक है, less than minus 2, sorry, the second one, ये तो हो जाएगा when x is greater than equal to 1, so this will open with positive sign, that is x minus 1. But when x is less than equal to 2, so it will open with less than 2, it will open with negative sign, that is minus of x minus 2 is greater than equal to 4. By solving this inequality, we are getting, see, no values of x, because this got cancelled. So minus 1 plus 2, that is 1. So 1 cannot be greater than equal to 4. So no values of x. Okay. So third case is x is greater than 2. X is greater than 2. That is modulus opens with positive sign. So what you have in the left hand side, just by deleting the modulus sign, just you have to write that left hand side. X minus 1 plus x minus 2 is greater than equal to 4. Right? So left hand side becomes 2x minus 3, and here we are getting x is greater than equal to 7 by 2. So by taking union of these two interval, we are getting the solution set is minus infinity to minus 1 by 2, union 7 by 2 to infinity. Is it clear to everyone, guys? Clear? Okay. Cool. Anyone having any doubt, you can ask. Anyone having any doubt, you can ask in this question. If you are having any doubt, you can ask. So let's move to the next question here. It's a very simple question actually. Number of solution of the equation tan x plus sec x is equal to 2 cos x lying in the interval 0 to 2 pi. So very easy question. How many of you got the answer of this question in the examination? Yes? Anyone? No one got the answer. Okay, see. Tan x plus sec x is equal to 2 cos x. It is given. Okay. Then try to convert tan x as, try to write tan x as sin x upon cos x. Sec x as 1 upon cos x is equal to 2 cos x. Okay. Then take the LCM. In the left hand side, you are getting sin x plus 1, and the denominator, multiply this to the right side. The right side becomes 2 cos square x. Okay. Then sin x plus 1, and try to write this right hand side as 2 cos square x can be written as 2 minus 2 sin square x. Okay. So now if we'll take this right hand side to the left hand side, so what will happen? What will happen? It becomes 2 sin square x plus 2 sin x minus sin x, sorry, 2 sin square x plus sin x minus 1 is equal to 0. Now it's a quadratic equation, and with the trigonometric ratios, you can split it. Okay, to the middle term, I am writing 2 sin x minus sin x. So by factorizing this 2 sin square x plus 2 sin x, okay, so from these two terms, I am taking sin x as common. So what will happen? Sin x, 2 sin x minus 1. Okay, and from these two terms, if I'll take plus 1 common, so this becomes 2 sin x minus 1, which is equal to 0. So finally, it becomes 2 sin x minus 1 into sin x plus 1 is equal to 0. So here I am getting 2 sin x is equal to 1. So sin x becomes 1 by 2. Sin x becomes 1 by 2, and from this sin x becomes minus 1. So when sin x is equal to minus 1, so x becomes 3 pi by 2. And when 3 pi by 2 does not belongs to, not possible, cos x is equal to 0. Since cos x is equal to 0, 2 pi. Yes, 2 pi by 2, 2 pi. 3 pi by 2 is actually 270. Oh, cos x is 0. See, the solution. Not possible when since cos x is equal to 0 at 3 pi by 2. Okay, at 3 pi by 2, cos x is 0. That is, right hand side becomes 0. And this becomes minus is infinity. This becomes infinity, and this becomes something. This equation is not satisfying when cos x is equal to 0. That's why x can't be 3 pi by 2. But when we are solving sin x is equal to 1 by 2, we are getting pi by 6 and 5 pi by 6. Okay, so these are two solutions. We are getting two solutions for which this equation is satisfied. Okay, the number of solution is 2. The correct answer is option C. Clear? Okay. Now, this is another question here. If the roots of the equation are real and less than 3, then, okay. In the question is asking if the roots of these equations are real. That means d is greater than or equal to 0, right? And less than 3. If you draw the graph, roots are real and less than 3. Suppose 3 is here. That means if you f of 3, second case, f of 3 is greater than 0. Yes or no? F of 3, this is my f of 3. So f of 3 is lying above the x-axis. That is, f of 3 is greater than 0. And another thing is the vertex minus b by 2a, x coordinate of the vertex is less than minus b by 2a is less than 3. So you can solve these three inequality and you will get the answer. By solving these three inequality, you will get the answer. Yes, try to solve these three inequality and you will get the answer. Location of roots wala question. Okay. Chalo, solve. See, first we are solving d is greater than or equal to 0. Second, we are solving f of 3 is greater than 0. And third, minus b by 2a is less than 3. So by solving these three, we are getting from all above, we can say a is less than 2. This is the solution. You can see here. It's an easy question actually. Clear? Shall we move? Let's move. The next question here from the quadratic equation again. If alpha and beta are the roots of this equation, x square plus 10x minus 7 is equal to 0. And if n is equal to alpha to the power n plus beta to the power n, for n is greater than or equal to 1, then the value of a12 minus 7 a10 upon 2 a11. Okay. Anyone of you got the answer of this question? Okay, let's solve. See, alpha and beta are the roots of this equation. That means alpha will be satisfying this equation and also beta is satisfying. So after putting alpha, we are getting this equation alpha square plus 10 alpha minus 7 is equal to 0. And after putting beta in this equation, we are getting beta square plus 10 beta minus 7 is equal to 0. Okay. So if you multiply alpha to the power 10 and beta to the power 10 respectively to both the equations. Okay. So if you multiply with this equation alpha to the power 10 and in this equation beta to the power 10. So what will happen? We are getting alpha to the power 12 plus 10 into alpha to the power 11 plus minus 7 into alpha to the power 10 is equal to 0. And In the second equation, we are getting, when we are multiplying beta to the power 10, what we are getting? Beta to the power 12 plus 10 into beta to the power 11 minus 7 into beta to the power 10 is equal to 0. Right? So if we'll add these two equations, so what we will get? Alpha to the power 12 plus beta to the power 12. What we are getting? Alpha to the power 12 plus beta to the power 12. Okay? See, alpha to the power 12 plus beta to the power 12. Second, 10. If we take add these two equations, we are getting 10 into alpha to the power 11 plus beta to the power 11. Similarly, minus 7. If I take minus 7 as common, then I'm getting say minus 7 into alpha to the power 10 plus beta to the power 10 is equal to 0. Okay. So if we'll take this middle term to the right hand side, 10 into alpha to the power 11 plus beta to the power 11, it becomes minus 10 into alpha to the power 11 plus beta to the power 11. Okay. So finally, what we are getting? We are getting alpha to the power 12. If we will divide alpha to the power 11 plus beta to the power 11 in both sides of this equation, what we will get? Alpha to the power 12 plus beta to the power 12 minus 7 into alpha to the power 10 plus beta to the power 10 by alpha to the power 11 plus beta to the power 11, and right hand side becomes minus 10 because this got cancelled. Okay. So similarly, what you are getting, actually we know ki in the question what we have, n is equal to alpha to the power n is equal to alpha to the power n plus beta to the power n. Okay. So if can I say A12 is alpha to the power 12 plus beta to the power 12? Yes. And what you are getting again? 7 into alpha to the power 10. So A10 becomes alpha to the power 10 plus beta to the power 10. And A11 becomes alpha to the power 11 plus beta to the power 11. So by substituting all these values, this becomes actually A12, this side becomes A12 minus 7A10 upon 2A11 is equal to this, which is equal to minus 10 upon 2, which is minus 5. So this is your answer. Okay. I hope this is clear to everyone. I hope this is clear to everyone, guys. Clear? Got it? So let's move. Okay, here you have a question from sequence and series. Okay, so to solve such type of equations, what should you do? Let's see. You have 10 to the power 9 plus 2 into 11 to the power 1. Actually, there are so many methods to find the sum of a series, everything. So if you're going to teach that, it will take a lot of time. So just I'm discussing the solution with you. Okay. So 10 to the power 9 plus 2 into 11 to the power 1 into 10 to the power 8, this series is equal to, given that, k into 10 to the power 9, and you have to find the value of k. What is the value of k? So let's see what is the solution. If I'll take, this is given actually, this is given, first line is given, and if I'll take the left hand side as x, so you can see here, let x is equal to the left hand side, and if we'll multiply 10 by 11 with both sides of this equation, okay, in this first equation, if I'll multiply 11 by 10 in the both sides of this first equation, so what will happen? So left hand side becomes 11x upon 10, and right hand side becomes, so when we'll multiply 11 by 10 with 10 to the power 9, it becomes 11 into 10 to the power 8. Yes or no? So that's why I'm writing 11 into 10 to the power 9 below 2 into 11 into 10 to the power 8, because it will be easy to subtract. Okay. Then multiply 10 by 11 with the second term and write here. Okay. Then multiply with this and the last one with the last one and write here. Okay. So by subtracting equation 1 and equation 2, what you are getting? See here. When you will subtract from equation 1 to 2, what you are getting? x into, if I'll take from the left hand side, if I'll take x as common, it becomes 1 minus 11 by 10, and right hand side becomes 10 to the power 9, 0, 10 to the power 9, 2 into 11 into 10 to the power 8 minus 11 into 10 to the power 8. So it becomes 11 into 10 to the power 8. Okay. So similarly, from these two terms also, we can subtract and we'll get 10 square into 10 to the power 7. And from here also, last 10 to 11 to the power 9 minus 11 to the power 10. Right. So you can observe here, the right hand side is a ZP, geometric progression, with the common ratio 11 by 10, and the first term is 10 to the power 9. So to find the sum of ZP, actually the formula is A into R to the power n minus 1 upon R minus 1. So 10 to the power 9 into R is 11 by 10 to the power 10 minus 1 upon 10 upon 11 upon 10 minus 1 minus 11 to the power 10. Okay. So after simplifying, what you are getting, x is equal to 10 to the power 11 is equal to k into 10 to the power 9. So k becomes actually 100. Okay, k becomes 100. Is that clear to everyone? I hope this is clear to everyone. Let's move to the next question. Okay, see, here you have an important question. There are two circles whose equations are x square plus y square is equal to 9. Another circle whose equations given as x square plus y square minus 8x minus 6y plus n square is equal to 0. So if these two circles have exactly two common tangents, then the number of possible values of A and R. Okay, so exactly two tangents, common tangents, they are having exactly two common tangents. So in which case they will be having exactly two common tangents? Is there any case? Yes. This is the case, no? Okay. So if you C1, C2, then C1, C2 is greater than R1 plus R2. Yeah, R1 plus R2 will be greater than C1, C2. Yes. So see, what is the solution? Okay. So the first circle having the center 0, 0 and radius is 3, and the second circle having the center as 4, 3, because here minus is 4 and minus f is 3. So in the second circle center is 4, 3 and the radius is under root of 4 square plus 3 square minus n square. Already I told you recently this to be defined 4 square plus 3 square minus n square must be greater than 0, and 4 square is 16 plus 9, that is 25 minus n square must be greater than 0 and root of this. Then this to be defined also, n square must be less than 5 square, because if n square will be greater than 5 square or 25, then the inner part of the under root will be negative, then the under root will not be defined. So that's why we are taking n square must be less than 5 square, that is 25, and this to be defined, n must be lies between minus 5 to 5. Okay, the circle should cut each other to have exactly two common tangents. So R1 plus R2 must be greater than D. Already we have discussed here. R1, the first radius, if the first radius is this and second radius is this, then R1 plus R2 must be greater than C1, C2, or here we are taking D, C1, C2 as D, the distance between the center. Okay, so this is greater than D. So we have both the centers. Na? This is 0, 0, this is 4, 3. So we can easily find D. So D will be under root of 4 square plus 3 square, that is 5. Okay, so we are getting here 5. 4 square is 4 square is 9 plus 9. 16 plus 9, that's 25. This is only, oh, sorry. 25, that is 5. 5 minus 3. Okay, is 2. So left hand side becomes root of 25 minus n square is greater than 2. Then if we'll squaring on both sides, if we'll square on both sides, it becomes again 25 minus n square is greater than 4. So if we'll solve this inequality, 25 minus n square is greater than 4. That means n square is less than 1, 21, or n square is greater than minus on root of 21. Okay, so this is the answer. Okay, so therefore the common values of n should satisfy this. So in between these minus on root of 21 and on root of 21, only we have 9 integers, that is minus 4 to minus 4 to 4. So minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 9. So we have 9 integers in for n. We are getting the value of n as 9 integers, starting from 4, minus 4 to plus 4. Is it clear to everyone? This is the case. Only what you have to do, just you have to solve this inequality, R1 plus R2. You know first what is the first radius, what is the second radius. We know the distance between the center of both the circles. So if you solve this inequality, you can easily solve the question also. Is that clear to everyone? Yes? Clear? Shall I move? So let's move to the next question. Wow. A circle 2x square plus 2y square is equal to 5 and a parabola y square is equal to 4 root 5x. Okay, and the first statement is saying an equation of common tangent to these curves is y is equal to x plus root 5. And second statement is saying if the line y is equal to mx plus root 5 by upon m, where m is not equal to 0, is there common tangent, then m satisfies this equation. Okay, let's see. That means you have to check whether statement 1 is true or statement 2 is true, and whether statement 2 is the correct explanation for statement 1 or not. These things you need to check. Okay, so let's move to the solution. We have the equation of parabola y square is equal to 4 root 5x. So here we are having a is root 5, and we know the equation of parabola is actually y is equal to m upon a upon x, right? A upon x. So that means equation of parabola becomes root 5 upon x. Y is equal to root 5 upon x. Mx, na? Sorry. Sorry. I did some mistake. Sorry. Actually, what is the equation of tangent to the parabola? That is y is equal to mx plus root 5. That is a upon x. Is that clear? A upon m. Sorry. A upon m. Okay. So if this is the equation to the tangent left, I am taking. So what is what here it is becoming? That is m into x plus a is root 5 upon a. So I am taking the tangent to the parabola is mx plus root 5 upon m, where m is not equal to 0. So its distance from the center of the circle. Circle क्या दिया हुआ है? That is 2x square plus 2y square is equal to 5. That is 2x square plus 2y square is equal to 5. Okay, if you divide, this becomes x square upon y plus y square 5 by 2. 5 by 2. Okay, so center is 0, 0. Circle of the center is 0, 0, and the parabola tangent to the both the common. It's a common tangent, na, to both the circle and parabola also. Suppose this is my parabola. So what we are saying, its distance from the center of the circle must be equal to the radius of the circle. That means distance from center to the tangent is equal to radius of the circle. Yes, why not? So we know what is the equation. What is the equation of tangent here given? That is, the equation of this line is y is equal to mx plus root 5 upon m. Clear? Okay. So we are getting, we know how to find the perpendicular distance from the center to from a point to the line. So by using that formula, we can find this, and it is already given that this becomes root 5 upon m, and by solving these two equations, root 5 mod of root 5 upon m is equal to root 5 by root 2 is into 1 upon root of 1 upon m square. So by solving it, we are getting m is equal to plus or minus 1. So the common tangent becomes y is equal to x plus root 5 and y is equal to minus x minus root 5. Okay. So the option B is correct. In my opinion, option B must be correct because statement 1 is true, statement 2 is false. Because here we have statement 2 is true if it is not given. So then m satisfying this equation. No, m does not is not satisfying this equation. What you are getting? Solutions. If you try to solve, it will be. So in the option, it is given that option A is correct and option statement 1 is true and statement 2 is true. Statement 2 is not the correct explanation for the statement 1. It is also correct. So we can consider the most correct answer is option. Okay. So you need to just find this. Just find this distance between center and line. Okay, and already you know what is the radius. Just equate these equations. What is the radius? Root 5 upon root 2. Root 5 upon root 2 and root 5 upon root 2, and this becomes root 5 root 5 upon m upon root of 1 plus m square. By solving these two, by solving this equation, you will get the answer. Okay, so that's all for today's, guys. Thank you all. You can drop from the call also. Bye bye. Take care because it's time to start the next